this first unit with a couple of word problems. So section 1.6 are just some simple applications. Or you can do complicated applications. You need to learn how to do simple applications. So we're going to do that. So I'm going to do the first example. You're going to do the second example. Both of these are super similar problems. They just involve addition in some way, shape, or form. So for all of us, because I know word problems tend to be intimidating. I doubt anybody here is salivating with love for word problems. Okay, so the challenge is in these problems, identifying what makes it an addition problem, so you know. Okay, so that's what we're going to try to identify. So example 1 says the painting, it should say the painting on the world's largest easel, because that wouldn't be really an interesting painting if it was a painting of the world's largest easel. Okay, the painting on the world's largest easel has a perimeter of 112 feet. I'm going to stop right there. What is the key word to that problem? Perimeter. If you don't know what perimeter means, circle that word. Perimeter means you add up all the sides. That's where the addition is in this problem. So when you go through and do your homework, you're going to see some perimeter problems. Perimeter just means add up all the sides. Okay, so the painting has a perimeter of 112 feet. The length is 8 feet more than its width. What is the length? Great. I'm hoping that once we've identified and gone through, you'll agree with me that this isn't a super complicated problem, but the challenge is in discerning the information. So I'm just going to draw a picture of the painting. So we have some people here. This person's sad. Excellent. There's my painting. So that doesn't matter, but it made me feel happy. So now what we're going to do is we're going to say, okay, the perimeter of this painting is 112 feet. We'll leave the units off till the end. The perimeter means I'm going to add up all the sides. So I need to know what the sides are. So I'm going to use a variable because I don't know what they are. So I'm going to read that second sentence again. It says the length is 8 feet more than the width. Which side, the length or the width, which side should I call X? The width, okay? You could do the length. It's a little more complicated, but it's doable. I'm going to call the width X because what I'm told in that sentence is once I know the width, how do I find the length? It's 8 feet more, right? So once you know the width, the length is plus 8. So the length is going to be X plus 8. So I know that's a challenge. Okay, taking information given to us in words and transcribing it to symbols is tough. So I'm not going to lie to you about that. But does anyone have a question right now, a concern right off the bat? When I put one of these on the test, people don't tend for the most part to struggle with it, but here is the one most common mistake that I'm going to clue you in on. When I go to find the perimeter of this rectangle, how many sides does it have? 4. Okay, so don't just add these two things together. So if you need to, I'm going to label all 4 sides just so I don't forget that I have to go all the way around. Perimeter means go all the way around your rectangle or triangle or whatever the figure is that you're asked to find the perimeter of. So here goes. I don't choose to memorize formulas when I don't have to. Some of you are thinking 2 times the length, 2 times the width. Go for it. That's fine if you love that. I'm just going to add everything up. I'm going to start over here on the left. That's X. The top is X plus 8. The right is X. The bottom is X plus 8. And then when I add all 4 of those sides up, I'm going to get 112. That's the hard part to any word problem, is finding a way to digest the information so that you can make the equation. My hope is once you've got the equation, that this is no big deal. This is not a complicated equation to solve. You're in college algebra. Most of you could probably solve this one in your head. X plus X plus X plus X, that's 4 of them. 8 and 8, that's 16. When I subtract 16 from both sides, I believe that gives me 96, probably. And then I divide both sides by 4, and that's going to be 24, I think. Then the last thing you're going to do for any word problem, okay, My Math Lab will prompt you to do this when you do the word problem, is you've got to answer the question. Okay, so the question here says, what is the length? It doesn't ask for both dimensions. If the problem did, you would give both, but all it asks for is the length. So x, is x the length? No, x we defined to be over here, the width. So if x is 24 feet, then what is my length going to be? 24 plus 8, and we were exactly right, 32 feet. So I'm just going to declare that because I'm so proud. The length is 32 feet. So example 2 is a little bit more, it's the same sort of thing. It's a little bit more complicated. So I'm going to give you 2 or 3 minutes to read through example 2. And to draw, I would recommend drawing a figure. It's not required, but in some way you should define your variables and define your sides and then solve that problem, answer the question. Okay, so when I start reading this problem, it says the perimeter of a triangular plot of land is 2,400 feet. So I'm going to stop there and get the information I need. The first thing I'm told is that the perimeter is 2,400 feet. So that tells me the relationship between all the sides. It tells me what I'm going to do with the sides. So there's a lot of information in that word perimeter. Again, if you struggle to find the information you need, circle the word perimeter, get used to looking for those relationships. I'm also going to draw a triangle so that I can know the relationship between the sides. So here is my good buddy, the triangle. And I notice when I read the problem, the sides are labeled longest, shortest, and middle. So this one clearly is the short one. This one, I guess, looks a little longer. And we'll call this one the middle. It really doesn't matter. Because I have to now determine the relationship. So whether or not you drew a triangle, that's immaterial. I like pictures, I'm visual. I like to do that. If that's not good for you, some way you need to define your variables so that you can figure out what an expression for each side is. That's kind of the key. So going on to my next thing, it says the longest side is 200 feet less than twice the shortest. 200 feet less than twice the shortest. So which side should I call X? Yeah, the shortest, because that sentence just said the longest side. It's defining the longest side, and it's saying the longest side is 200 feet less than twice the shortest. Once you know the shortest, 200 feet less than twice the shortest. Now here's probably the one thing that'll trip up a lot of you. Okay? That's why I put this problem on here, is I want to make sure that we do this properly. The expression for 200 feet less than twice the shortest. What is that going to be? Give me a hypothesis here. Perfect. Thank you for saying that. Okay, so this is what I expected. This is not right, but it's okay. That's why I put this problem. Okay, so there's no shame in missing this. Okay, so if you got this wrong, which I'm guessing is a lot of you, okay, it's okay. The word less. If you have $5 less today than yesterday, where do you start? You have $5 less today than yesterday. Do you start with 5 or do you start with how much money you had yesterday? Start with yesterday and then you take 5 away. That word less, it confounds a lot of us. Okay, I totally understand it. Okay, when you say something is less than another thing, the order is reversed. So in this problem, what we're going to do is we're going to start with twice the shortest side, and then it's less 200. We're taking that 200 away. So whoever answered, thank you for your boldness. I appreciate you putting yourself out there. Okay, but you don't also know you are not the only one. I guarantee it by a long shot. Okay, because even though I've made this big production out of mentioning this, when I put this same thing on the test, people will miss this. Please don't miss this. Okay, understand what that word less than is telling you here. Okay, I've said enough about that. The middle side, this one up here, the middle side is 200 feet less than the longest. Okay, so we get our chance to redeem ourselves on this word less. So the middle side is 200 feet less than the longest. So what's the longest? Perfect. 2x minus 200. And then the middle side is 200 less than that. Now, if you are adept enough, and there's probably some of you in here that are, you could have just written down 2x minus 400 all at once, and that's totally fine. But I just want for your notes, for you to be able to see where that comes from. So there's my short side, we defined to be x. The first sentence told us that once we know the short side, the long side is 200 less than twice that. And then the second sentence told us that once we know the longest, the middle is 200 less than the longest. Okay, so here's the expression for the longest, minus 200. Difficult problem, and I get it. Any question? Anything that you're still fuzzy on that I'm not doing a good job explaining? All right, well, maybe you want to talk after. You don't want to raise your hand. Don't be shy in here. It doesn't accomplish anything. So now the perimeter, I'm just going to take those 3 sides. I'm going to start over on the left. I'm going to go clockwise. So the short side is x. The middle side, if you don't mind me collecting the like terms, the middle side is 2x minus 400. The long side down at the bottom is 2x minus 200. And that equals 2,400. That's difficult. That's labor. But I'm going to put something like that on the test. So be ready. The solving of this, again, I think you can do this in your sleep. X plus 2x is 3x, plus 2 more, that's 5x. Negative 400, negative 200 is negative 600. When I add the 600 to both sides, I get 3,000. When I divide both sides by 5, I get x is 600. Great. So I'm going to end this by answering the question. The question is, find the lengths of all 3 sides. Okay, great. I can find the lengths of all 3 sides. Okay, so the short side, we already know. 600 somethings feet. The middle is, what's the middle going to be? 2 times 600 is 1,200, 1,200. Minus 200 is 1,000. Minus 200 is 800 feet. And the longest is 2 times 600 is 1,200. Minus 200 is 1,000 feet. Hopefully those last 2 bits are not the stressful part. Hopefully solving is not stressful. Hopefully answering the question is not stressful. But I get how coming up with this equation can be stressful. Okay, so identify what the relationship is. In this case, it was perimeter. Look for words like total or sum, SUM. Those things all mean that you're adding stuff up. That's going to be what generates the equations for the first type of problem you're doing. Okay, the second type of problem on the next page, called a mixture problem. So we do mixture problems in intermediate algebra, but we do them in the context of systems of equations, which we have not talked about or gotten there yet. So we're not going to use to solve these. So we're going to just use one variable. I actually think it makes it easier to do the problem this way than with the system of equations. Again, if you have me for intermediate algebra, you've already seen this. I have no new things in my bag of tricks. But for those of you who haven't had me, I need to make sure we understand how percents work, because that's sometimes something that we forget and we leave in arithmetic or economics class or something like this. So you go to the store and you buy a new pen. Okay, we'll use this one. So you go to the store and you're going to buy a can of juice. So here it is, whatever juice you like. Today it's apple juice. And you're all happy about your decision to drink something healthy and drink some apple juice, but then you get up to the register and you notice that your 1,000 milliliters of juice is really only 70% juice. So there's sugar and other junk in there. So here's my question. If I ask you, out of the 1,000 milliliters, if it's 70% juice, how will we figure out how many milliliters are actually juice? What do we do? Any remembrance on how percents work? I'm sorry, I just didn't hear. You're going to turn it into a decimal. Great, that's a good first thing to do, because percents, you don't use the percent. This is telling you the ratio. So what is the decimal that goes along with 70%? 0.7. I'm just going to write 0.70, so in your notes you recognize that's where it came from. And what am I going to do with that 70%? What am I going to do with that 0.70 and the total amount of juice? You're going to multiply it. Yes. Okay, perfect. So 70% of all of the volume in that jug is going to be 700 milliliters. So out of the 1,000 milliliters of liquid, 700 of them are juice. Okay, just want to do this, a simple little demonstration, just to remind you and get it clicking in your head how percents work, so that when you see these percents in the mixture problem, you're like, oh, no big deal. I understand how percents work. So let's read example 3. Example 3 and example 4, very similar. Once you've done one mixture problem, you've done them all. Okay, it's just a matter of remembering how to get the information out of this, and I'm hoping I can help you with that. So example 3 says, how much pure alcohol? I'm going to stop right there. If something's pure, what percent is it? 100%. So you might put in parentheses right above that 100%. Okay, just so you know, if something's pure, it's 100%. So how much pure alcohol should be added to 20 liters of a 40% alcohol solution to increase the concentration to 50%. Okay, so you're in chemistry or you're wherever, your job as a chemical engineer, and you have to take this percentage you have on hand and you have to make it stronger. Okay, so how would I do that? How would I figure out how to make that stronger? Great question. Okay, so there's other ways to set this up. Again, I told you I'm a visual person. I like pictures. If you just want to use like a little table, that is totally fine. But I'm going to draw a picture. So I'm going to draw a picture of me in the chem lab mixing these things together. So here is the box that represents what I'm starting with. Okay, so I'm just going to write the word I'm starting with this. And then I'm going to add to it something. We're going to define these things. Okay, so this box represents the volume of what I've started with. This is going to represent the volume of what I'm adding. And then over here, here's my equal sign. This box represents my result. So tell me, according to the problem, what am I starting with? What kind of solution? For a 40% solution. So I'm starting with a 40% solution. What that means is in this box, if this box is full, then if 40% of it is alcohol molecules, I don't know if you've had chemistry or not, but any alcohol, whether it's the one you drink or the one you use for other things, is alcohol molecules inside water. Okay, so 40% of this is alcohol molecules. So like right here, that's the alcohol. The rest of this is water up here. How much is the volume of this? 20 liters. Everyone see where I'm getting this information? I know mixture problems are difficult, and I'm trying to make them as simple as I possibly can. And the way you're going to remember this is by practicing. There's several of these in your homework that you're going to encounter. We good so far? I'm starting with 20 liters of a 40% solution. Okay. What am I adding to this? I'm adding pure alcohol. I'm adding 100%, meaning everything in the box, the whole volume is alcohol molecules. How much am I adding? Unknown. So when we don't know, what are we going to use? Our favorite letter. I'm going to use X, but if you have a different favorite letter, use it. That's fine. I just want to time out. In the homework, it's not always going to be pure alcohol. This same setup would work if I told you it was an 80% solution or a 75% solution, or if you're trying to decrease the concentration, if it was a 20% solution. The setup is exactly the same. Okay, so don't worry about that. It's not always going to be pure, but the setup will always work. Okay, now I'm going to come over here. My result. What am I hoping for? In my box, I want half of the box to be alcohol molecules, 50%. Here is probably the first thing that we have to make sure we understand. If you start with 20 liters of something, so I've got a big barrel with 20 liters, and then I have a jug and I'm adding in my alcohol. What's the volume that I have over here? 20 plus whatever I add. Yeah, you're exactly right. We started with 20 liters and we added some unknown quantity of pure alcohol, some liters. That's the hard part of this problem. And I know it's hard. I know it's difficult to disseminate the information and get it into a way that we can view it and process it. I like pictures. The book, they'll do if you go into the ebook that you have in my math lab, if you would prefer, they set theirs up with like a little table, a little spreadsheet. That's equally fine. Do that. Okay, I don't care about the particular setup. I just want you to have a way to get the information down on the paper. Now that we've done that, if you remember how percents work, you are golden. So now, how much alcohol? That's not a question for Friday night. That's the math question. Here we go. If 40% of this 20 liters is alcohol, then just like we said for the apple juice, that's 0.40 times 20. That's how much alcohol is in that box right there. Plus, what's 100% as a decimal? 1 point, we always move the decimal twice, so it's going to be 1.0. Okay, if you have one of something, you have everything. Okay, so 100% as a decimal is 1.00 times x. If this was 80%, you'd use 0.8. If it was 25%, you use 0.25. This setup works no matter what the percents are. And then on the other side, I have 50% of my volume is alcohol over here, so 0.50 times 20 plus x. Percent times volume, percent times volume, percent times volume each time. And again, once you've done that, solving this, not too big of a deal. You've got calculators, you're welcome to use them. So 0.4 times 20, that turns out to be 8. 1 times x is 1x. 0.5 times 20, half of 20 is 10. And then 0.5 times x is 0.5x. I'm going to put all my x's, well, you have two options here. I'm fine with decimals. I don't mind working with decimals. I love them. So I'm just going to keep going. If you don't like decimals, if you like whole numbers, what would you multiply every term by here if you want to get rid of the decimals? I'm sorry, I didn't hear what you said. You could do 2. That's clever because 2 times this would make 1. But I was thinking in more general terms, if this wasn't 0.5, it was like 0.2 or something. If I want to move the decimal one place, I would multiply by 10. Okay, that 10 would be the thing that worked all the time, but you're totally right. 2 would work in this case. You could do that. I'm just going to stick with the decimal. I'm going to subtract 0.5x from both sides to get the x's over there. So 1x minus 0.5x is 0.5. Oops, 0.5x. And then I'm going to subtract 8 from both sides. And so 10 minus 8 is 2. And when I divide both sides, and you use your calculator to do this, when I divide both sides by 0.5, I get x is 4. And so what that means is how much pure alcohol am I going to add? I'm going to add 4 liters. Okay, so example 4 is very similar. Just want you to go through the process of setting it up and seeing what you remember, what you forget, what you need to ask questions about. So I'm going to give you 3 or 4 minutes to setting it up is the most important part. So 3 or 4 minutes to do that. All right, I'm gonna get started on this. If I set anything up in a different way than you did, if you don't see what I'm doing, it's a perfect opportunity to ask a question. It's the same sort of thing. A chemist wants to strengthen a mixture from 10% to 30% alcohol. How much pure alcohol? So again, it's pure. How much pure alcohol should be added to 7 liters of the 10% mixture? Okay, so once again, here's my box that represents what I start with. And here's the box that represents the stuff that I'm going to add to that. And then here's the box that represents my result. And we're going to go from here. So I start with a 7 liters of a 10% mixture. So I've got 10%. So only like this much of the box is actually alcohol molecules. The rest of it is water. And so the total volume there is 7 liters. Then I'm adding to this, again, it's pure alcohol. So that means everything in the box is an alcohol molecule. So 100%. But again, I don't know how much I'm adding. So there's that. And then the result is I'm hoping, I don't even know what I'm saying anymore. I'm hoping, that's better. I'm hoping to make this into a 30% solution. The volume is going to be the amount I started with plus the amount that I add. So 7 plus x, or x plus 7, doesn't matter. All right, I've got that. I'm ready to rumble. So using my percent times volume, 0.10 times 7. Plus 1.00 times x is 0.30 times 7 plus x. Okay, I'm going to stop for a moment because that's the new and different and difficult stuff to this problem. Is there any question or stumbling block or anything that we need to go over so far? We're going to 11:45 no matter what. So you can ask a question or don't if you have it. So finishing up here, 0.1 times 7, that's 0.7. Then I've got x. Then I've got 0.3 times 7 is 2.1. And then 0.3x. On this problem, the numbers are going to work out good, but I just want to show you, in case you don't want to work with the decimals, I just want to make sure that I show you what I meant by multiply everything. So I've got to multiply the decimal places I've got to move the decimal one place. So I'm going to multiply everything in this equation by 10. That's going to move it at once. If you have to move everything 2 decimal places, you do 100, 3 decimal places, 1,000, whatever the problem requires. So 10 times 0.7 is 7. 10 times x is 10x, 10 times 2.1 is 21, and 10 times 0.3 is 3x. If you didn't do that, it's fine. We're going to end up with the exact same answer, so don't worry. Put my x's on the left, numbers on the right, so I'm going to subtract the 3x and get 7x. I'm going to subtract the 7 and get 14, and when I divide, I get x is 2. So the answer is how much alcohol do I have to add to this? I'm going to add 2 liters. My original 7. All right, we've got a few minutes left, so we just got a couple more problems. Flip to page 3. We're going to start at the bottom of this page, and then if time allows, we'll do the example 5 at the top. If time doesn't allow, it's not too important to our future. So here's what I would like you to do. At some point, you've seen things with variables and hoping that this doesn't look too mysterious. I want you to use your powers of solving on example 6 to solve that formula for the little a. Okay, do your best. At the very least, you should be able to clear the fraction. Okay, that's my hope. Just to keep us on the same page, I'm hoping you can at least clear the fraction. What am I doing to both sides of this to clear the fraction? Right. The other option is you can distribute the 1/2 h if you want to, if you like working with the fraction. So keep working. I'm just going to multiply both sides by 2 and get us to that next step. You have 2 options at this point. It doesn't matter which one you do. So I'm just going to rewrite that because I'm going to show you both ways, because I'm guessing it's probably like a 50-50 split on what people did, or maybe it's not that, but I just want to make sure. So first thing you could decide to do, this is what I would do. This is how I see the problem. I would go ahead and distribute the h, get rid of the parentheses. Okay, so I've got 2a is equal to ah plus bh. If you have HA, HB, that's fine. I always do alphabetical order just to keep things straight. And so then I'm asked to solve for the lowercase a. So I've got to get the lowercase a by itself. So what do I need to move first from this right side of the equation? Yeah, so I'm going to subtract that. Okay, so it's the same steps that you've employed before. In case you've not done formulas before, it's the same steps you've employed before, just now you can't collect like terms because they're not in. Okay, so you're going to add and subtract, or you multiply and divide, whatever. So here I've got 2a minus bh. Those are not like terms. Don't force them together. On the other side, I've got ah. One more step. How am I going to get this a by itself? By the h. Now, this is the first of about 1 billion times I'm going to say this semester. You cannot cancel things unless you can cancel from every term on a fraction. Okay. So if at this point you said, ho, h's, and cross it out, that's wrong. Okay, so don't mess up at the very end. Okay, because there's no h over here to cancel with. So the final answer here is going to be this. I've got a on the lowercase a on the left, or on the right, which is what I wanted. And then I've got 2 capital A minus BH over H on the left. Questions about that? The other option some of you might have pursued, and this is perfectly legitimate, is at this point you might have said, well, you know what? I've got H times this, so I'm just going to divide by H right now. Okay, that is fine. So on the left, then you've got 2 capital A times H. On the right, you have A plus B. And then at this point, to get the A alone, you're going to subtract B. Now notice, all of this is one term. So the left side is going to be 2 capital A over H minus B to the side. Don't put the minus B up there in the top. It's not part of the fraction. And then that's going to equal A. Which, by the way, that's the same thing we would have gotten if we had distributed the H here. But both of those are equivalent. The processes, either one is better than the other. So whatever you did there is totally fine. So here's our last problem for the day. Do the same thing on example 7. Solve example 7 for L. That's actually a little bit easier of a problem. Probably should have done that first, but that's okay. Nice cool down exercise. I'm solving this for L. There's my L. What's the first thing I've got to do? Move the 2W to the other side. How am I going to do that? So I have P minus 2W. Those are not like terms. Don't combine them. On the other side, I've got 2L. The second and final step is to do what? And so this, I would not do any more than this, P minus 2W over 2, but I know some people want to do a little more. You can reduce this if you distribute. So if you rewrite this as P over 2, you divide the 2 into the P, minus 2 goes into 2W, leaves W. That's optional. I wouldn't even bother. It's more work than you need to do, but you're welcome to do that. So hang on, we got a minute or two more. I'm going to shut off the recording.